This is SpaceTime Series 28, Episode 25, for broadcast on the 26th of February 2025. Coming up on SpaceTime, physicists discover 2 arrows of time emerging from the quantum realm. NASA's Perseverance rover finds new kinds of rocks which could be the oldest ever found on the red planet Mars. And stand by for the launch of NASA's Lunar Trailblazer mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Einstein has already shown us that time is malleable. It slows down as you increase in speed and as you get closer to a massive object. But now physicists have discovered evidence for what appears to be 2 separate arrows of time emerging from the quantum realm. The discovery, published in the journal Scientific Reports, poses the fascinating proposition that opposing arrows of time can theoretically emerge from certain quantum systems. So once again, we have to face the idea that time is not as fixed as we thought. Imagine that instead of flowing in just one direction from the past to the future, time could flow forward or backwards due to processes taking place in the quantum level. For centuries, scientists have puzzled over the arrow of time, the idea that time flows irreversibly from the past to the future. Now, while that seems obvious in our everyday lives, the way we experience reality, the simple fact is the underlying laws of physics don't inherently favour a single direction. Put simply, whether time moves forward or backwards, the equations remain the same. The study's lead author, Andrea Rocco from the University of Surrey, says one way to explain this is like looking at a process where spilt milk is spreading across a tabletop. Now, by watching that happen, it's clear that time is moving in one direction, forward. After all, that's how entropy works. And if you were to play that in reverse like a movie, you'd immediately know something was wrong. It would be hard to believe that milk could simply gather itself back into a glass. That's not how entropy works. But then again, there are other processes, like the motion of a pendulum, that look exactly the same and believable whether the movie was played forwards or backwards. The puzzle is that at the most fundamental level, the laws of physics resemble the pendulum, not the spilt milk. Consequently, they do not account for irreversible processes. Rocco says that while the findings suggest that our common experience tells us that time only travels one way, we're simply unaware that the opposite direction would have an equal possibility. The study was exploring how a quantum system, that's the world of the subatomic, interacts with its environment in what's known as an open quantum system. The authors investigated why we perceive time moving in just one direction, and whether this perception emerges from open quantum mechanics. To simplify the problem, they made 2 key assumptions. First, they treated the vast environment surrounding the system in such a way that they could focus only on the quantum system itself. And secondly, they assumed that the environment, like the entire universe, is so large that energy and information dissipate into it, never returning. And this approach allowed them to examine how time could emerge as a one-way phenomenon, even though at the microscopic level, time could theoretically move in both directions. The problem is, even after applying these assumptions, the system still behaved in exactly the same way, whether time moved forward or backwards. There was no difference. The discoveries provided a mathematical foundation for the idea that time reversal symmetry still holds in open quantum systems, suggesting that time's arrow may not be as fixed as we experience it. The authors also found a small but important detail which is usually overlooked. They discovered a time discontinuous factor that keeps the time symmetry property intact. It's unusual to see such a mathematical mechanism in a physics equation. That's because it's not continuous, and Rocco says it's very surprising to see it pop up so naturally. I guess this research is offering a fresh perspective on one of the biggest mysteries in physics. Understanding the true nature of time could have profound implications for quantum mechanics, for cosmology, and, well, for everything else. And I guess if you still want to explode your mind, well, try explaining to a 5-year-old exactly what time is. This is SpaceTime. Still to come, NASA's Mars Perseverance rovers discovered some new kinds of rock, which may be the oldest material ever found on the red planet. And it's all systems go for NASA's next moon mission, Lunar Trailblazer. All that and more still to come on SpaceTime. NASA's Mars Perseverance rover has discovered some new kinds of rocks on the rim of Jezero crater, which may be the oldest material ever found on the red planet. The car-sized six-wheeled mobile laboratory is now engaged in what's known as the Crater Rim Campaign. It's looking for ancient uplifted rock in order to better understand the geological processes occurring in early Martian history and to search for ancient habitable environments. And recent discoveries haven't disappointed. So far, in this portion of the rim that it's been exploring, every outcrop that the rover's taken a close look at has ended up providing something new. After acquiring the Silver Mountain core, which is rich in the mineral pyroxene, Perseverance approached a nearby rock that had signatures of the mineral serpentine, which has been fittingly nicknamed Serpentine Lake. Following this, the rover used its abrasion tool to clean this rock with dust and coatings in order to carry out a detailed scientific interrogation. And the science team were stunned by the intriguing rock's texture, which actually resembles a cookies and cream type dessert. It contains a very high abundance of minerals like serpentine, which form in the presence of water. After finishing that investigation, mission managers decided to have Perseverance double back to the site of its first abrasion in this part of the rim, named Kadam Reservoir, in order to acquire a sample. Results from that earlier analysis showed a rock texture with coarse pyroxene and feldspar crystals consistent with an igneous origin. However, the sample tube turned up empty. Now, it's not a common occurrence, but sometimes the rocks Perseverance tries to sample are so weak that upon coring they essentially disintegrate into powder instead of remaining in the tube. The rover drove to a nearby spot and tried again. But when a second attempt at coring this rock also failed to retain a sample, mission managers decided to move on. This week, mission managers will once again return to the site of the Serpentine Lake abrasion patch in order to acquire a core sample of this fascinating rock, which records intense alteration by water. And fingers crossed, scientists are hoping it will prove strong enough to acquire a core, and if successful, Perseverance may perform more scans on the abrasion patch. Afterwards, the plan is to drive downhill to an area called Broom Point that's home to a spectacular sequence of layered rock. And who knows what exciting new discoveries the mission will make there. This is SpaceTime. Still to come, NASA's Lunar Trailblazer about to blast off on a new mission to the Moon, and later in the science report, a new study claims that the artificial sweetener aspartame could increase your risk of a heart attack or stroke. All that and more still to come on SpaceTime. NASA's Lunar Trailblazer mission is about to blast off on a journey to the Moon to search for water ice. The Trailblazer spacecraft has now been incorporated into its SpaceX Falcon 9 launcher in preparation for the 2-year mission. Shipped from Lockheed Martin Space in Littleton, Colorado, the flight from Launch Complex 39A at the Kennedy Space Center in Florida is part of NASA's Commercial Lunar Payload Services initiative. The probe's riding along on Intuitive Machines' IM-2 spacecraft. Approximately 48 minutes after launch, Lunar Trailblazer will separate from the rocket and the primary payload and begin its own independent flight to the Moon. It'll use the gravity of the Sun, Earth and Moon over several months to gradually line up for lunar orbit insertion. Once in orbit, it'll look for where the Moon's water's located, what form that water's in, and how it changes over time, producing the best yet maps of water on the lunar surface. The observations gathered during its 2-year prime mission will contribute to an understanding of water cycles on airless bodies throughout our solar system, while at the same time also supporting future manned and robotic missions to the Moon by identifying where water can be located. Key to achieving these goals are the spacecraft's 2 state-of-the-art science instrument packages. There's a high-resolution volatiles and minerals Moon Mapper infrared spectrometer and a Lunar Thermal Mapper infrared multispectral imager. The high-resolution instrument was built by NASA's Jet Propulsion Laboratory in Pasadena, California, while the thermal mapper was built by the University of Oxford in the UK. But before it can use these instruments to collect scientific data, Lunar Trailblazer will spend several months performing a series of lunar flybys, thruster burns and looping orbits. These highly choreographed maneuvers will eventually position the spacecraft so that it can map the surface in great detail. Weighing only 200 kilograms and measuring just 3.5 meters in length, and that's with its solar panels fully deployed, Lunar Trailblazer is no bigger than a dishwasher and has a relatively small engine. To make its 4 to 7 month, depending on launch date, journey to the moon, the mission's design and navigation team have planned a trajectory that will use gravity assists from the Sun, Earth and Moon to guide and slingshot the spacecraft into its correct position, a technique known as low energy transfer. The initial boost provided by the launch vehicle will send the spacecraft past the moon and into deep space, and its trajectory will then naturally be reshaped by gravity after several lunar flybys and loops around the Earth. Trailblazer's mission design and navigation lead, Gregory Lantoni from JPL, says this will allow the spacecraft to be captured into lunar orbit with minimal propulsion needs. After all, the less fuel you need, the more payload you can carry. As it flies past the moon several times, Lunar Trailblazer will use small thrust-to-burst trajectory correction maneuvers. They'll slowly change its orbit from highly elliptical to circular, bringing the satellite down to an altitude just 100 kilometers above the moon's surface. Once in its scientific orbit, Trailblazer will glide over the moon's surface, making 12 orbits a day and observing the surface at a variety of different times of the day over the course of its mission. And the spacecraft will also be perfectly placed to peer deep into the permanently shadowed craters near the moon's south pole. These craters harbour cold traps, areas on the floor that never see direct sunlight. If Lunar Trailblazer finds significant quantities of ice on the crater floors, those locations could be pinpointed as a resource for future lunar explorers. Mission scientist Kerry Donaldson-Hanna from the University of Central Florida says the high-resolution maps of water ice on the moon created by Lunar Trailblazer will help researchers understand where water exists on the lunar surface and play a key role in the future of manned exploration of the moon.
Lunar Trailblazer is a small satellite spacecraft that has two main instruments. It has two spectrometers that are going to be looking at different parts of the electromagnetic spectrum. So we're going to be looking at signals of sunlight that's reflected off the surface of the moon. And then we'll also be looking at the heat that's emanating from the surface of the moon. And so this small satellite will go in orbit about the moon and collect data and help us understand how water exists on the lunar surface, where it exists, how much of it exists. And then we'll also be looking at different interesting geologic landing sites for future exploration. The Lunar Vice team is super excited about Lunar Trailblazer because Lunar Trailblazer will carry a thermal infrared instrument that will be looking again at the heat that's coming off the surface. And this will be similar to an instrument that will be on Lunar Vice on our rover. And so we'll get really high spatial resolution from lunar orbit, looking at the Gruithuisen domes, and will give us a sneak peek at what we're going to be able to see with our thermal infrared camera when Lunar Vice gets to the Gruithuisen domes. So the instruments are very small, but where the solar panel arrays are actually much larger, but still in that sense, it's a very small spacecraft. The main goal of Lunar Trailblazer is really to study the water cycle on the moon. We have all this remote sensing observations of the moon that suggests that water is there, but we haven't made a definitive detection of water at the surface. And so we don't really know, when we talk about water, is it actual H2O that's attached to different minerals, or is it oxygen and hydrogen in the form of hydroxyl that are just attached that might come from the solar wind? We also don't know if there's maybe water ice. This has all been suggested to be there, but we haven't had definitive identifications of it. So permanently shadowed regions are actually at the north and south pole of the moon. And so when we think about the Earth, as an example, when we're spinning on our axes, it's actually bent. The moon isn't. It's actually pretty perpendicular. And so what that means is that there's some areas at the poles that get absolutely no sunshine. And so there's bottoms of impact craters that get no sunshine. And so because they get no sunshine throughout the year, they're called permanently shadowed regions. And so they're truly the only spot on the moon that are dark. While water on the moon is certainly very exciting, I think some of the things that excite me most are actually looking at other parts of the lunar surface. And so we're going to target key areas of geologic interest to really use these new instruments to look at them in new wavelengths and in more detail. And so things like the Gruithuisen domes and other areas where we see silicic volcanism, we're going to have new spectral coverage and higher spatial resolution data that will help us better understand how these silicic magmas form. And then I'm also really curious about this area or areas across the lunar surface called anorthosites. And so this is the original crust of the moon that formed. And this is something that I studied as a graduate student. And so we're going to be able to study these regions of pure anorthosite across the moon, which will really help us unlock and understand how the moon's crust formed. And so I'm super excited about that.
That's Lunar Trailblazer mission scientist Kerry Donaldson-Hanna from the University of Central Florida. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that one of the most common sugar substitutes, aspartame, can spike insulin levels and build up fatty plaque in arteries, increasing your risk of a heart attack or stroke. The findings, reported in the journal Cell Metabolism, show that foods containing aspartame, equivalent to about 3 cans of diet soda a day, developed larger and more fatty arterial plaques and showed higher levels of inflammation. The authors believe that because aspartame is around 200 times sweeter than sugar, it's able to trick receptors in the intestines to release more insulin, which in turn causes the heart issues. A new study claims Australia's LGBT+ community has more than doubled between 2012 and 2020, rising from 0.58 million to 1.18 million people. The study claims the LGBT+ population made up just 3.3% of the population in 2012. But by 2020, that had increased to 5.8%. The findings, reported in the journal Population Studies, are based on the long-running government HILDA survey. HILDA is representative of the population aged 15 and over, apart from very remote parts of Australia, and has been conducted regularly since 2001. The authors say more men than women identified as LGBT+ in 2012, but that had reversed by 2016. And the survey suggests that the LGBT+ community is mainly young and getting younger. The authors say the growth in the LGBT+ community has primarily been driven by young women who are now identifying as bisexual. They conclude that the size of the change suggests Australia is in the midst of a remarkable demographic and social transformation, and the growth of the LGBT+ community may continue. Of course, there's one big problem with the survey. Multiple previous studies dating way back to the 1980s and 90s had already established that around 5% of the Australian population, in fact 5% of the world population, is gay, lesbian or bisexual. So in reality, in terms of the overall LGBT population, not much has really changed. Now, speaking of surveys, a new survey shows that around 1 in 10 Australians have already used ChatGPT to ask for medical advice. The findings, reported in the Medical Journal of Australia, are based on a questionnaire filled out by 2,000 people during 2024. Participants were asked whether they were aware of the artificial intelligence chatbot and whether they had used it to ask medical questions. They say 84.7% of participants knew about ChatGPT and 9.9% had already used it to obtain health-related information, while a further 38.8% were considering doing so in the next 6 months. Questions most frequently related to a specific health condition, finding out what symptoms mean, finding actions to take, and understanding medical terms. They also found that some 61% of participants who had already asked ChatGPT for medical information had asked the question that would typically need a doctor's input. The survey also found that people who face barriers to healthcare access, such as those with limited English or low health literacy, were more likely to end up using ChatGPT. Well, Apple's just released its new affordable iPhone 16e. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Apple has launched the iPhone 16e. This is the replacement for the 2022 iPhone SE model, which was the last one to feature the home button, the traditional home button, and also the thick bezels at the top and the bottom. And for those who are on an older iPhone still, like an iPhone 8, you can buy those refurbished from around about $300, which would be a great upgrade for somebody on an older device. But for those wanting to get the latest latest Apple Intelligence features, including visual intelligence, where you can hold your phone in front of anything, the Eiffel Tower, flowers in your garden, whatever it might be, and ask ChatGPT what it can see. This is the cheapest way to get this capability. It's starting at $999 in Australia and $599 in the US for the 128 gig model, and it goes up. Now, it's the same size as the iPhone 14, the 6.1 inches, also the iPhone 15. It has the notch, so it does not have the dynamic island, but it does have the A18 chip. And now, that's not the A18 Pro that's in the iPhone Pro 16 and Pro Max models, but it is more or less on par with the A17 Pro chip from the year before. So it's got basically the latest chip. There is still an A18 Pro, which is in the iPhone 16 Pro models, but we're clearly talking about the value end of the iPhone scale, and enough memory to do Apple Intelligence. It's got a 48 megapixel camera, so you get the ability to do a clean 2x optical zoom. You can zoom in the pixels basically without any degradation because it's delivering you a 12 megapixel or 24 megapixel photo depending on which mode you're using, but it's got the 48 megapixel camera. Now, you don't have obviously the ultra wide, you don't have longer zooms, there's only one camera, not two or three. So this is an excellent way of getting into the Apple ecosystem, but with effectively the latest tech. Now, you do have competition with the iPhone 15 Pro models. I see them online for as low as $1,149, but that's in good condition, not very good or excellent, being refurbished. And again, as I said before, we have the iPhone SE from 2022. I see them online refurbished from about $300. So if you're on a budget, there are alternatives. It's often said that Apple's biggest competitor is not sub-$500 Android phones or the flagships from Samsung and Google, but itself, its own older models, which for many people, if they're on an iPhone 10X, or the 11 or 12. I mean, if they want to upgrade to something with a faster processor, this is a great way of doing it.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.